Hello, welcome everyone. So this is going to be a recorded lecture because I'm going to be unavailable to give a live lecture on Monday. It'll be posted today on Saturday when I'm recording this, and you'll be able to watch it. I wanted to go ahead and get this out here now because for the quiz on Monday afternoon that you'll be getting a Microsoft form based quiz, some of the material that we cover in here, there's going to be ER modeling on the quiz, and so I wanted to make sure that you had access to this discussion soon so that you could prepare. Okay, there's other stuff on the quiz too. There's not just the ER modeling stuff, but that is part of it. So, all right, so let's just go ahead and get straight into it. There we go. Okay. So where we left off was we talked about the different types of relationships. We talked about let me back up. Let me actually back up to here. Okay, so we talked about this where we had the one-to-one relationship, the one-to-many type relationship, and the many-to-many type relationship. And where we ended was it was on this slide about the many-to-many relationship. All right, so that's the general idea. So when you see the two dots like this is not the same thing as I wish I'd kept track of what slide it was. That was this one here. Okay, so when you see the colon style like this is the idea of, okay, one what is it? One entity to one entity, right? So it's the entity to entity type relationship. So one to one, one to many, many to many. When you see the colon like this, that is what is the general idea on one side of it? What's the general idea on the other side of it? Okay, but even within these sides, there's cardinality and participation, and that's what we're going to talk about today. Okay, so we're going to talk about the multiplicity and the cardinality and participation and all this kind of stuff. So I'm going to kind of skip over this whole ternary relationship because we talked about this, the idea of having, the three entities involved in a relationship. But generally, most systems don't use a lot of these. That most of the relationships you'll encounter are going to be this binary relationship. So we're gonna get into today some more about what all of these numbers with not the colon but the two dots kind of horizontal like this, what that means. Okay, all right, but first let's give a summary of some of these multiplicity constraints. All right, so if we see this kind of 0, 1, that means that it could be 0 or it can be 1, but that's it. Like there can't be any more than 1 on this side. So the idea here is that participation is optional. We don't have to have 1, but if we do, we can only have 1. So this would be an example that gets commonly thrown out there would be a significant other like a husband, wife, or a dating relationship like a boyfriend or a girlfriend. Ideally, you can be single. You don't have to have one. You don't have to have a boyfriend or girlfriend. You don't have to have a husband or wife. But if you do, you should only have one. Okay, so if you get more than one, there's problems and just not a good idea. Okay, one and only one, or we could just write it just as one, and this kind of means the same thing, is that it's like participation is required, and if you do have one, you can only have one. Okay, so this would be like if for me I'm working at the department, the computer engineering department, on that side of that relationship, there's one and only one. I only work for one department. In order for the university to keep track of me, I must belong to a department. I have to belong to a department, but I can only belong to one of them. Okay, 0 to many, participation not required, and I can participate as many times. The side of this can participate as many times as they want. This could be like having children. If you have a parent has a relationship with the child, They don't have to have they don't have to have children. A person doesn't have to have any children. And if they do, they can have many, right? There is no limit to how many children you can have. A one to many. Oh, simple shorthand, we could just write this as star, right? Okay. You can even set up some particular constraints, like it must have a minimum of 5, cannot have any more than 10, or even some specific types of numbers, so 0, 3, or 6 to 8. Okay. There's all kinds of different ways that we can write this. All right. So again, I said we want to talk about these special words, cardinality and participation. So cardinality in each of these cases is the kind of the second side of this. So the star here, the star here, the one, sorry, over here, the star here, the star here, the one here. Okay, would be the cardinality. Participation is the other side. It's whether or not participation is required. Okay. All right. So if we look at it like this, some examples here is a staff manages a branch. So this would be the manages relationship. Lots of different information we can understand from this. We know that a staff does not have to manage a branch. We could have a staff member who's not a manager. That's okay. A staff, if they manage a branch, they can only manage one of them. A branch must have at least one staff person as a manager. A branch can only have one staff person as a manager. Okay, so the way that we would read this is, so if we think of the two left numbers here, the participation numbers, right? All branches are managed, so there must be a manager that exists. So participation is mandatory on the branch side. Okay, for the branch must participate in this relationship. Not all staff manage branches, so optional participation for staff means a staff person doesn't have to be a manager of a branch. Cardinality, one branch is managed by one member of staff. One member of staff manages one and only one branch. So in other words, you cannot have a staff person that manages more than one branch. Okay. So this is some different ways that we can look at this. Okay. So there are some problems that can arise with ER models that we'll refer to as traps. So there's two main types of traps called fan traps and chasm traps. Each one gets their name from the way that they look when we diagram them. Okay. I bounced up there. Okay. So an example of a fan trap is whenever there's a pathway between two different entities that should have a type of relationship, or we should be able to learn things about the pathway from one to another, but there's ambiguity because we don't know how to get there. Let me just show you an example. That's probably the best way. Okay, so here, if we were to design our ER diagram like this, where we would say a division, think of this as a department. Okay, department, like at the university, has staff. So if we say a department has teachers, that'd be another way, right? This looks right. This looks normal, right? A one-to-many type relationship where a department has many teachers, right? And we could also say a department, or in this case, the example here is the division operates of branches. The way we would look at this, maybe this could be the courses, right? So we say the department offers courses, and this looks like the normal type of relationship here too, right? The department has many courses. A course belongs to one department. Yeah, that looks right. Okay. So what's the problem? Think about it for a second. Maybe pause the video to think about why you might think this is a problem. Pause the video and I'll give the next slide in 3, 2, 1, and So if we look at the semantic net for this, where we have the division has the many relationship with staff, division has the many relationship with branch, right? Well, the problem is now, if we want to know SG37, what branch does that person work at? Well, we don't know. It could be either one of these two, can't it? Or if we think of this in the university example that I gave, a department has teachers, a department offers courses. Let's say Joseph is over here and CSE 204 is over here. Well, which course does Joseph teach? Well, we don't really know based on the way that we've designed this, right? And we call this a fan trap because you see how it kind of fans out. If you think of a fan, I don't have an example here, but a fan, like where you fold it up and you unfold it, right? That's kind of what it looks like here, right? It kind of fans out, all right? So what we need to do to solve this problem is really, we should change up the order of how we did this. So instead of having a department or a division offering or operating branches, what we this might be better. This, the course thing probably actually should go the other way. Now that I think about it, but because the teacher would be this one. This course has a teacher. Okay, so I did this one a little bit opposite, but I guess really maybe it'd be better if we think of it as faculty, department, and teacher. Maybe that'd probably be a better way to think about it. Okay, so let me go back a couple of slides then and say it that way then. Go back and undo what I just said earlier, and we'll say department has staff, a department, a faculty has staff, a faculty has departments. Okay. All right. So if we look at it this way now, division operates branches and branches have staff. Now, you may think, well, we lost that relationship between division and staff. We don't know what staff's in what division, but we actually still do. Because if we look at the semantic net, now we have a division that operates branches and branches have staff. Right? So now if we want to know what branch does SG37 work at, we know that. But we still know what division SG37 is in. Why? Because we can look through the branch to get there. Okay, so we haven't lost any information, right? But we've gained. So if we think of it the same way as the faculty, department, and teachers, same thing. Engineering faculty, computer engineering department, Joseph. All right, so Joseph is in the computer engineering department. That is in the engineering faculty. We can look through this table or this entity to get here. Okay, so we've solved that fan trap. Okay. Basically, anytime, let me go back to the original problematic diagram. Anytime you have a one-to-many relationship like this and a one-to-many relationship like this, but there could exist a relationship between these two, chances are you have a fan trap. Okay. And what type of relationship exists here? Well, staff work at branches, so there must be a one-to-many relationship. So instead of having a one-to-many here and one-to-many here, we could do a one-to-many to branch and then another one-to-many. And guess what? We haven't lost anything. Okay. That's not to say that there's always a fan trap here, just because there's a one-to-many on one side and a one-to-many on the other side. But if there is a relationship we need to know here, we don't just add a new relationship. All right? Because what we're going to find when we get into the normalization lecture next time is that when we do that, if we add a different relationship here, there's a whole lot of new stuff that we have to deal with. That's a problem. Okay. All right. All right. So we restructure like this with the fan trap removed and the new semantic net. Okay. The chasm trap happens when there's a relationship that exists between two other sides. Now, this time it's a one-to-many and a one-to-many. So you think, oh, that's not a problem, right? But where a relationship that exists here, but we might not know it. We might not know how this a row over here relates to a row over here. A record over here to over here, because it may not exist between here. So remember, earlier I gave the example where we had the faculty, the department, and the teachers, right? And because a teacher had to belong to a department, we could tell what faculty they belonged in, right? We could tell that information from that. But here, now we've lost that because since a property for rent in this example is not required to be overseen, see, it doesn't have mandatory participation, it has optional participation here. When a property for rent does not have to be overseen by a staff person, but it still belongs to a branch, we don't know it. We don't know which branch it is. So let's take a look here at this semantic net for this. So now you have branches have staff, staff oversees properties, but here we have this property, PA14. It's not being overseen yet. It's not being overseen, but it still belongs to a branch. There's still a branch who is keeping track of that one, of that property. We just don't know what it is because there's no linking there, right? There's no relationship here. Okay. So unfortunately, we will need to have a second relationship here that tells us which branch offers that property. Now, adding this extra relationship, again, as we'll see next time, does come with its own complications that we will have to keep track of, but it's the only way to solve this problem. So basically, because this participation is optional, but we still have a relationship between property for rent and branch, we must use that. Okay, so here the semantic net looks like this, where now branch has staff that oversees the property for rent, branch offers this property for rent. Notice one thing, I'll just go ahead and give you a heads up, kind of a little reclam for the future, is what's going on here. The reason why this is going to be it's going to have its own complications in the future is because notice that this branch offers a certain property. So a property for rent, the way we could learn what branch it's associated with is through this offers relationship directly to the branch. Or we could also learn which branch it's being offered by looking through the staff relationship, through the staff entity, right? Now, what happens if somehow the branch offers, well, let's say we changed B003, we changed PG36, we changed it to being offered by B007. Now we have one branch through the offers relationship and a different branch through the staff entity, right? That's a problem, isn't it? That would be a corruption of data, right? And so that's something that databases are intended to avoid. We don't like data corruption, right? And we like data consistency. Maybe not data corruption. I'm sorry, not data corruption. Data inconsistency. Data corruption is something else. But data inconsistency, and one of the nice things about relational databases is that we can maintain um, data consistency. So anyway, all right, but because this relationship might not exist, because this relationship may not be participated in by the property for rent, in order to find out what branch offers it, that we must have this relationship here. Okay. All right. So those are the two traps. Oh, one key here I want to make sure you understand. If this participation is not required, if we have a one-to-many and a one-to-many, and the participation on this side is not required, as shown here, you likely have a chasm trap. If the participation is required, we do not have a chasm trap. So basically, if you see a 0 right here, that's probably that. And if I say, hey, there's a trap in this diagram, and you see a one-to-many followed by a one-to-many, and if I say there's a trap in here, chasm trap. Okay, chasm trap if this is not required. Okay, if I show you a diagram that has a one-to-many followed by a one-to-many, and participation is required, not a chasm trap. Okay, so the other example that we looked at here, no, that's the restructured. All right. If you see a one-to-many and a one-to-many where the one on each side is in between, is inside of it, right? Is the between one here? Okay. And I say there might be a trap in here. That's a fan trap, right? Because it fans out on each side. Okay. All right. Where am I? Okay. Let's move on. We're going to finish up the ER modeling slides today, I believe. So far we've shown you basically relationships between entities, the one-to-many, one-to-one, many-to-many type relationships between the between two entities. Those of you who are thinking back in your mind to the UML days, you're saying to yourself, there was something else though. I remember in UML we talked about this idea of parent-child relationships. There were other types of relationships. Okay. Well, guess what? We got those here too. Okay, a superclass and a subclass. So the superclass is like the parent type. The subclass is the child, just like in UML. All right. So one thing that we'll talk about is here. Not all members of a superclass need to be a member of a subclass. You can have, what's it called? You can have abstract and non-abstract. The way we'll do that here in database will be different. There'll be some differences, but yeah, there'll be some differences, but there are some main similarities in the ideas behind them. Okay. So, let's just go ahead and get on into it. So let's say that we have a relation that's all staff, right? And there are some attributes that all staff are going to have. Right, so you guys would remember this as being the staff would be like the parent class, right? Or in this case, entity. All right, and so there are certain relationships, certain attributes that exist in all, right? And then we would inherit certain attributes for branch managers, for sales, for secretarial. This would be like administrative assistants who we need to know their typing speed for some reason, right? Well, I guess because they do a lot of typing. I don't know, right? So this is some examples of things we might need to know specifically for certain types of staff, right? Okay. So just like in UML, the way that we would draw this in the diagram, this nice little triangle with a line here. Okay, it is a one-to-one relationship in the sense that, so this one-to-one, by the way, goes over here to the branch. Don't put that over here on this line. That's not where it goes. It's focused on this line over here. Okay, it is a one-to-one relationship. Because a manager can be staff, right? A manager is a staff person. A sales personnel is a staff person. A secretary is a staff person. Right? Notice we put their attributes they all have in common, their common attributes here. We put their specific attributes here. Okay. We have this extra information about this that's optional, and what that means is that if a staff person exists, they can be a manager, they can be a sales personnel, they can be a secretary, okay? But they don't have to be. They could be just a staff person. They don't have to be any one of these specific. Okay. The and, so that's what the optional means. The and means that I'll be done in a few minutes. The and means that they could be more than one of them, right? They could be a manager and a sales personnel, so they could be a sales manager. They could be a sales personnel and a secretary, right? They don't have to just be only one of these. Okay? So this is a little bit different from UML and Java, right? They'll be a little bit different from UML and Java. Remember, in UML and Java, if you had one of these, you could only have one. Right now, there were in addition to parent classes, we also had the whole interfaces thing. So it's kind of like that, but again, because this is database, it's going to be a little bit different. It's going to function a little bit differently. Okay, so optional and as we'll see on the next slide, some other possibilities, right, is mandatory or. Okay, so you have a staff person. They could be a manager. They could be a sales personnel. They could be a secretary. Notice here also the manager type is the only one that has this relationship with branch. Isn't that nice? Remember before we had this whole double relationship between staff and branch, where we said a branch has staff, a staff manages branch, and it was confusing, maybe a little bit confusing, and we'd have to put all these extra checks in place to make sure that a branch only had one and a staff could only have one, if we do it this way, where we have this this specialization here, where a manager type of staff is the only thing that can manage a branch. Wow, right? We've been able to remove some of that confusion of the double relationship. This will also make our database design much easier and much cleaner when we get there. Okay, and so this is a nice extra feature here. But the optional and see here still exists. So it's optional, means could be just a staff, could be one of these, and means it could be a manager, and it could also be a sales personnel, and it could also be a secretary. It's like it doesn't have to just choose one of them. Okay. So notice the second one over here, a staff person, mandatory or. Okay. What that means is that if a staff person exists, they cannot just be a staff person. They have to be full-time permanent, or they have to be part-time temporary. Okay. They must be one of these. Mandatory or, so that's the mandatory part, they must be is mandatory, or means if they are one of these, they cannot be the other. Okay, so think of this as not or like digital logic or, where it's 1 or 1 equals 1. This is more of like an exclusive or, okay, where it can only be one of these. So if you are full-time, you cannot be part-time. Kind of makes sense, right? If you are part-time, you cannot be full-time. All right, makes sense. Okay, and a staff person could move from one to the other. Maybe they were full-time, but they decided to become part-time for a while due to some COVID issues or something. I don't know. Or they were part-time and they, the company has really liked their work, so they want to promote them to be a full-time employee. Yeah, something like that. All right. And so there's 4 different possible combinations, right? You could have optional and, optional or, mandatory and, mandatory or. Okay. You will need to know you will need to know what the 4 different combinations would mean. Okay. All right. So if I were to give you this diagram, let's say I were to give you this diagram right here, and I were to say, if a person is a staff person, can they be a full-time permanent manager? And you would say yes. Okay. Can they be a part-time, just a staff, not one of these 3? And you would say yes. And I would say, can they be a manager and a salesperson and not one of these 2? And you would say, no, they can't be that. All right. So that would be something you would need to be able to tell me. Another thing that we can do to be even more refined is add some more child relationships, where here a sales manager is both a manager and a sales personnel. Now, because the and exists here, that makes this possible, right? Because they can be one of both. If this was an or, then this would not be possible, right? Because if this were an or, they could not be both of these, so that a child of someone who is both of these is not possible. Okay. Here, a secretary might be an assistant secretary, right? And we have another more optional participation. So notice here, we have a staff person who could just be a staff person, can be any one or more of these, could be one of these, right? And because all of these are optional, and this, you could have a person that is a sales manager, assistant secretary. That'd be really weird, but it is possible, because since a sales manager could exist and that sales manager could also still be a secretary, a sales manager secretary is possible. A sales manager assistant secretary is possible. That would be very strange, but I guess it would be possible. Okay. All right. So again, let's see. Here I want to talk about this real quick. Again, the whole disjoint and non-disjoint. That's that whole and or part of that relationship. So you could have a mandatory disjoint, mandatory or. Okay. Optional disjoint, optional or, mandatory and, optional and. Okay. So a couple more examples and then we'll call it a day. So here you have a staff person who has an optional or possible with a manager and a supervisor. What does that mean? What does optional or on a staff person mean? I'll let you pause the video. And in 3, 2, 1. Optional or means you could have someone who's just a staff person. You could have someone who's a supervisor. You could have a staff person who's a manager. If they are a supervisor, they cannot be a manager. If they are a manager, they cannot be a supervisor. If they are neither a supervisor nor a manager, that's okay. All right. And here, notice we've refined some of this other relationship too. Remember, we had this recursive relationship that existed with staff to say if a person was being supervised, right? The supervises recursive relationship, we've gotten rid of that because we're saying the only type of staff who can supervise other staff are supervisors, right? So it's a special relationship now, not just this general recursive relationship. The manager, same as before. If a manager staff person exists, they manage a branch. Okay, so we have this relationship over here. So we kind of, we've added some visible complexity, but we've also refined some of the meanings of those relationships. That recursive relationship didn't necessarily say that the staff person had to be a special supervisor staff person, but now that exists there, right? So we've really given some more information to our diagram, which is very helpful. Okay. Here, another example. And we've got one more example after this. We've got an owner who owns property for rent. All right. An owner, mandatory or on private owner or business owner. Okay, so here, here we had the owner must be either a private residence owner or a business place owner, right? And so if they are one, they cannot be the other. All right. Okay. So they're mandatory, must be one or the other, can only be one or the other. These mandatory ors and optional ands and all that stuff, it's going to get really important for us to understand this when we start designing the database itself. And what's going to happen is how these different entities become the relations, the tables, when we create our database is going to be different based upon these types of relationships. Okay, and then that'll be clear when we get there. All right. But notice that we can have a single owner that owns a property for rent, right? A property for rent is owned by one owner. Now we don't have to have two separate tables. Oh, it could be owned by a private owner or it could be owned by a business owner. We can just say it's owned by an owner. And an owner is one of these two. Okay. All right. So here we can even have a higher class now, even some more general attributes for particular types of things, right? So we'll discuss this in 3. I'll let you pause the video to consider this diagram. And in 3, 2, 1. So the way we would look at this is we have our database contains people, right? We're going to keep track of people, of person objects or person rows. And every person is going to have some things in common. A number, so an ID, a name, maybe an email, a phone number, all kinds of things, right? All right, there's all kinds of things that all people have in common, right? Now, if a person exists in our database, they must be one of these things, or they can only be one of these things. All right. So if a person is a staff person, they cannot be a private owner or a client in our database. And this probably should have been owner actually, but anyway, it's fine. If an owner exists, they cannot be a staff or a client. If a client exists, they cannot be a staff or an owner. They can only be one of these things. If a person is a staff person, right, and they must be one of these. If a person is a staff person, this is the same discussion we had a couple slides ago. They can be a supervisor, they can be a manager, they could be just a staff person, but they're going to be one of those 3 things. They're going to be either just a staff person, they're going to be a supervisor, or they're going to be a manager. They cannot be someone who is a supervisor and a manager. Okay. Oh, that would make for a good quiz or exam question, right? So I give you something like staff, supervisor, manager. Which of the following, multiple choice, which of the following is not possible? Someone who's just a staff, someone who's just a supervisor, someone who's just a manager, someone who is a manager and a supervisor, right? And which of those is not possible? A, B, C, or D. and you would have to give that as an answer. All right. Or, up here, a person exists. Which of these is not possible? Someone who's just a person, someone who's just a staff, someone who's just a private owner, someone who's just a client. And in that case, you would say someone who's just a person, right? We don't keep track of people who are just people. We keep track of people who are one of these things because there's the mandatory thing. Okay. All right. Well, that will end our discussion. Unfortunately, I can't take any questions because none of you are live attending this lecture. But I hope that was informative and clear. And good luck on the quiz. Like I said, it covers this set of slides as well as the last discussion as well, or previous discussions as well. So everything you should know, the things that we've discussed there. So, all right. Have a good Monday. I will see you live on Tuesday morning. All right. Have a good weekend.